One of the very nice presentation of the functions, it is called the parametric representation. What means? That means let us, to understand this representation, we consider the motion of the particle. That means, of course, to find the path and how it is one coordinate dependent on the independent coordinates, we must write the following function. That means let us, for a simple case, possible to consider motion of the particles on the plate. That means a two-dimensional motion. That means that it is necessary to find fx. But sometimes it should be enough difficult to find dependence on y coordinate to x coordinate. That means this is the coordinate system. That means here is the x, this is the y. That means this is the particles move along, for example, this curve, which, as you see, very complicated track of motions, but sometimes very easier because it is motion. That means that it is occurs. That means the time is passed. Therefore, possible to take t as a parameter and separately define the dependence respect to this parameter t, the coordinate x. That means the motion in the x direction and motion in y directions. In the course physics, you also consider that type of motions. That means this is we present, instead to present the motion by these functions, we write y will be function of the parameter t. That means it is considered as a parameter, and x also will be function of t. This is called representation of these functions. That means here's a parameter. Let us consider some simple examples. That this is also possible to write. For example, this is defined by function f. This will be maybe some gt. I will consider these motions. That means the x depend on t square. Sometimes when you will read the chapter concerning the parametric representation of the function, maybe you confuse it, because now here I will take the t and write the t x coordinate equal to t square. That you see, as usually in the physics, when you equal two quantities, they must have the same units. That means the x in the meter or centimeter or kilometer. That means that this is the time in the hours, minutes, seconds. How possible to equaling? But in the Mathematica, it is all such quantity hasn't dimension. But to show you this, that means the letters I will write, because this is depend on t square. That means the letters we consider the motion. That means x equal to a t square by 2. You know this motion is called accelerated, uniform accelerated motions. That means now I can transfer that. I will define a u variable. That means u variable t prime as possible to take that it will be equal to t under root a, that 2 divided to a, 2 divided to a, 2 divided to a, and times t. That means you see, if this is second, this, because this is the A accelerations, and after, because here the x equal to, after that, when you extract from here the roots and multiply to second, you receive here the dimensionless variable t. Therefore, therefore don't be confused when you meet such relation, because in the mathematical all quantity dimensionless. Therefore possible to write such relation. That means that I consider the parametric representation of x as a t square, and y should be equal to t plus 1. And t, it is a time, it is a change from minus infinity to plus infinity. Well, that means if you would like to find what will be in this case the dependence of y to x, but possible here to find the inverse function. That means the x as a function of y. Why? Because from here I will find the t. You see, t should be equal to y minus 1. Minus 1. And substitute to here, that means the x will be equal to y minus 1 square. That means if you like now to find what will be dependent, that means that this is inverse function. If your direct function, if you like, find as a y, you take the roots from both sides. That means the x. Here will be u minus 1, and therefore u should be equal to under root x plus 1. But this is also define some that means the inverse function. That okay. Sometimes because when you make some experiments, that means you consider the motion of the particles, as usually for parametric representation, t, it is some independent variable. It is as usual, it is a time. I will show you the other examples. That means we make the table. That means like this. Here the value, that means the x. Here the here's the t, sorry, t, here's the x, and here's the y. And that means that here's this x equal to t square and y equal to t plus 1. And we begin to write, to take the different values of the t. That means the minus 3 here will be equal to 9. Here will be minus 2. Then minus 1. Here will be 1. That this will be 0. 0. That means if you take the 0, here will be 0. This will be t, that means a 1. And 1. If you take the 1, this will be x will be 1. Here will be 2. And at last, I will take the 3. That means here will be 9. Here will be equal to 4. That means now possible to plot the graph of this function. It is here I will take the x. Here we will take y. That means when x equal to 0, it will be y equal to 1. That means that this is a 1. Then for negative, that means for negative values, it will be minus t. That means here. That means you will find this graph in the books. That means that this will be like this graph. This will be parabola. Respect to parabola like this in respect to y-axis. That means this defines the motions. Sometimes this parameter may be not only time, but also maybe other some quantity. I will consider the following examples. I will consider the gas is some vessel, and assume when temperature increases proportional to the temperature, that means the mass of the gas is not changed. Mass of gas is not changed. When I will take the but volume possible change. That means that if you increase the temperature, for example, if you take the some ball from rubber, that means that if the temperature increases, that means always the volume increases of that. I will assume the following behavior of that means the pressure with the temperature. When pressure increases, that means I will write here the P naught, that means N0 temperature, multiply to T temperature, volume I will volume change it, decreasing. That means if the temperature decreasing, P is decreasing, that means here's a V naught by T. You see, in this case, if I exclude this formula, T, this parameter now the temperature, that means multiply to this to this one. That means the PV, you receive P naught to V naught, because T cancel. That means this is in the physics it is called the Boyle-Mariotte equations for gas, for ideal gas. Therefore, that means also possible to consider other some example, but I have no time to consider all equations when not only T may be parameter, maybe temperature, and maybe some other parameters, also temperature. Let us consider the following examples. That means of motion of the particle. Example 4. The position p xy of the particles moving in the xy plane is given by the equation and parametric intervals. That means x equal under root t. Again, I repeat once more, t, it is a time, because we consider the motion. But don't confuse that coordinate, I equal it under root t, because I told that in the mathematics all quantity dimensionless. Y equal to t. T larger than 0. That means t equal to 0 is the initial time of the fixed motion of this motion. Identify the path traced by the particle and describe the motions. That now I take this again. I will take that because the t equal to y. Therefore, here possible to substitute y. That means the x will be under root y. So now I will take the from here square. That means the y will be x square. That means that this track trace defined by this equation. That means there should be parabola. If you would like to plot this parabola, it will be like this. Here's a y, here's a x. In other case, will be the parabola respect to axis. Okay, we consider other some interesting motion. You know, when you consider rolling of some cylinder on the horizontal plane, that means we consider rolling. That means that this is a horizontal plane. Here's some cylinder, which is rolling with the constant velocity. That means the center of mass of this cylinder moves with the constant velocity. That what will be? That means if there is no slipping, in this case, this point of the cylinder has a zero velocity. That means it is particles move in this direction. This is the velocity v, which is possible to this equal to 1, and the radius also possible to 1. That means its motion will be in these directions. Now, after some times, position of to find, it is necessary to consider. That means I will take this, some radius, which is equal to 1. Radius, angular velocity also equal to 1. Angular, that means the velocity equal to 1. Angular velocity equal to 1. And so I can write the motions of the particles. You see, that means here's the radius. Here's the radius, the distance which is passed by particle. I will write a. That means in this position, it is not equal to this cylinder. Let us assume when it is past some distance a, that means this is defined the distance which is passed. Here the velocity, if you take the that means x, this is the x, and here's possible to take the y. That means here's a y. That means now this radius will be not in the initial point. It is because it is moving, it's come to this position. That means now it comes to these positions. That means this position, if this distance, I will take AT. So x, that means I would like to find the position of this radius, this end of the radius, because this will be, you see, the end of the radius which is moved should be here. That means how to find? That means that to this distance, it is necessary to add this distance, which is equal to this one. If this angle I will theta, that means the x, position of this x coordinate of this point, that means this point. That means here is also this point. Will be equal to AT plus cos theta, because here's the angle, I will take the theta. Well, what will be y? Y coordinate of this will be equal to a here. That means if this is radius a, let us here the radius a, here the radius a, that means this will be a plus this, that means a plus this distance, which is equal to a sine theta. That means a, it is a radius, that means we receive a multiple. Don't confuse, because I again repeat once more that all quantities dimensionless. Therefore here's a at. Now it is necessary to find the, because the theta changed, because you see initially theta will be small and then that. What will be this total, this angle? Total this angle will be equal to 3 by 2 pi. Because here's if the total angle, that means if you will be one rolling, that means one motion, one revolution will be, angle will be 2 pi. But from the 2 pi, it is necessary to subtract this one. Therefore, or possible to take the following. That means that to this angle, it is necessary to add this angle. So let us, therefore I will take that theta should be equal to, because it is rolling with the constant velocity, therefore I can write theta plus t should be equal to 3 by 2 pi. 3 by 2 pi. Therefore, theta should be equal to 3 by 2 pi minus t. That means that you see again, angle will be equal, as usually angle, it is necessary the time multiplied to angular velocity. But angular velocity, that means again I transferred to so make this dimensionless. This is angle also, because angle dimensionless, that means as usually this t, it is omega multiplied to t, and you take the omega equal to 1. Therefore, for angular velocity multiplied to time, you must add this angle theta, and you receive exactly this angle, 3 by 2 pi. Therefore, from here you receive this one. Now I substitute here. That means the x will be a t, because center of mass moves with the constant velocity, plus cos 3 by 2 pi minus t. Y should be equal a plus a sine, here will be 3 by 2 pi minus t. That means using the property of sine, and this will be minus sine t, this will be minus cos t. And so, after simplification, using the property of cos and sine, I get, that means the x should be equal to at minus sine t. Sine t, here I forgot a. Here's a sorry. A, here also a. That means that here will be equal to minus a sine t. And y will be equal to a minus cos t, also a. Or this is this possible because a the same, therefore x should be equal to a has a t minus sine t, and y should be equal to a has a 1 minus cos t. That means this behavior. If you would like to have the dimension quantity, that means here, because here's a defined angle, that means you must multiply to omega, angular velocity, and this multiply to angular velocity. In this case, you receive the dimensionless quantity. A will be in centimeter or in the meter, if it depends on the, choose what units you apply. Okay, that means therefore the parametric representation very convenient for this type of motion. What will be in this case track of the motion? You see, in this case the track of the motion will be like this. That means here it go to this, like this. That again it is this radius again will be the same situation in the side, and then again go to like this. It is a little larger. If it will be a motion, if that's under acceleration motion, of course this distance will be shorter and shorter. Well, let us now how possible to find some length of the path in this case. That means I will take in general case. That means I will decide that here x should be equal to f t and y should be equal to gt. That means only two quantities, which is defined coordinates in the plane, and here the t is a parameter. It's possible to consider as a time. That let us now, I will define this derivative. That means the derivative the y to the x. How to define these derivatives? That means to find the derivative, that you must possible by use a formality that possible to take the sum for this and to take the limits. That means let us now, I will find what will be definitions. You see, definition of the limit. That means the dy to the x should be equal to limit when delta x go to 0, delta y to delta x. This is definition of derivative. Let us now here, because x depends on the t, that means also changes. Therefore, delta y possible to write that is as f t minus f t naught. That means this, which is initial time, and delta y, delta x will be, sorry, this is a g. G. This is a G. That this will be F T minus F T naught. That means this is should be equal to delta G. This equal to delta G. This is should be delta F. Delta F. So that here possible, that means if you substitute to here, that means dy to dx will be equal to limit. Here, delta y, I will write delta g to delta t, delta f, and here the delta t, that delta t is equal t minus t naught, which is go to 0. Or so this possible to rewrite by following way. That means this is will be equal to divided by delta t by and this I will divide it by delta t. That means that this is possible to write limit delta t go to 0. Here will be delta g divided to delta t, and here the delta v divided to delta t. That means this will be derivatives of g. If I will take using the property of limits, that means that this is the limit of, that means that this is give us derivative of g, here the derivative of f, relative to t. That means we receive g prime t to f prime t. That means I applied the definition of the limits, but possible to make by other way also. You see, that means dy to dx possible directly to write dy to the x times, that means the delta divide, that means here the x, here possible to write that delta t dy to delta t, and here divided, here there will be dx to delta t. Because you see that why it is possible to write like this. That here I will write, that means that here I will, here the dx, here I multiply dt to dt. Right? That means that I combine that dy to dt, it will be derivative. That means that dy to dt. This divided to d, it will give us derivative of x. That means this should be equal over, here will be dx to dt. That means that we receive the same result, which is this. Here I multiply dt and receive this result, which is so simple. Let us we consider some Now I would like to find the second derivative using this property. Second derivatives. That means the second derivatives should be the following. That means the second derivatives d2 dx square dy, possible to write dx, here will be dy to dx. Again, using the same things, that means that this will be y. This should be equal to following. That means multiply and divided by t. That means here's a dt and here's a dt. I receive that this is from this it is necessary to take derivative, and from this it is necessary to take the derivative. Therefore, I receive the equation dy prime to dt, and here there will be dx prime to dt, where prime means derivative over the t. Oh, sorry, dx, this. Here's a without prime, dx, because here, from here I will take, this is the derivative. That means the dy to dx. And other equation. Let us, we will find the derivative of the following parametric representation of the curves. Sec t and y equal to tan t. T, it is changed from minus pi by 2 to plus pi by 2. That means the time changes in this interval. Dy to dx, which is equal to dy to dt divided to dx to dt. So this will be equal to tan theta prime over x. That means that this will be second theta prime. That means the prime derivative over the t. So this is give us second square. This will be sec square t. From second, this will be second plus that seconds times tangent. That means the second t tan t. So this will be possible to cancel this and this. So we have the 1 sec t over tan t. That, if you like to find what will be and some point, its value, you insert from at some point from these intervals. Well, as an example you find in the book, now I would like to find the length of the curve presented in by parameter representations. Again, in general case, let us, in the curve on the plane, determined by parametric representations. That means the x equal to ft and y equal to gt. And here t changed from alpha to beta. That means that we have the same curves. This is the initial point, this is the final point. That is, here I will write the A, here the B, here, that means that this is X, this is the Y. This is the C point, this is the D point. When alpha changes from alpha to t, that means the coordinate changes from x coordinate from alpha to the b, y coordinate changes from the C point to D point. To D values, sorry. That's how now we will find the length. That means, you know, to find the length, it is necessary what to do. That means you must separate all this curve by many portions. That means like this. That means approximately possible, and connected this, I will connect this by this one, this point, this, and so on. That means there are several n portions. That means I divided this line to n portions, which is, as usual, should be enough small. That means when the number of portions will be larger and larger, the distance between the length of this portion will be smaller and smaller. That means the sum of the segments, which is defined as the motions, should be closer and closer to this curve. That means I will write now the length L I will find delta LK is any, let us, I will take this is delta LK, some k number of portions will be equal to under root delta XK square plus delta YK square. So such portion will be n. That means the total length L should be equal to closer and closer. That is, usually it is necessary to take the limit. Limit, which is delta t. That means the parameter go to 0, delta t go to 0, and here will be under roots. That means delta LK. That means, sum, I forgot the sum. That means the sum k from 1 to n, that when delta t go to 0, that means interval for motion on this part, because the number of intervals go to infinity. So this is delta LK, or this will be equal to sum limit delta t go to 0 and go to infinity. That means the sum k from 1 up to n under root delta xk square plus delta yk square. This is, but this is a sum, it is a Riemann sum, which is possible to write by following way. Let us, I will take, that means I make the following. That means delta xk, that means delta xk possible to rewrite, and like this, multiply delta xk, I will divide it by delta tk, and multiply delta k. Here the same, that square, sorry, that means I will make the following. That means the delta xk, I square, multiply delta tk square, divided to delta tk square. The same, delta yk square, I multiply to delta tk square and divided delta tk square. But when you see this ratio, delta xk to delta t, that means it is possible to write under one square delta tx to delta t. Therefore, this will be derivative of x over the t square. This is derivative of y. And this is delta k and delta k is the same. Therefore, it's possible to extract from root. And the limit, because this will be reduced to following integral. That means that this will be integrals. That means this will be integrals. Here will be under root. Here x prime square plus y prime square. That means derivative over t and dt. Integration over t, that means the integration over t, that means this interval integration from alpha to beta. That means this is give us derivative. Or if you prefer other notations for derivative, that means it's possible to write L will be equal to integral from alpha to b, here under root dx to dt square plus dy to dt square and integration over t. That means if you like this and this, it is the same. Okay, this is examples of calculation we consider during the interactive sessions. Maybe Monday, maybe Thursday. Okay, finish.